Okay, for number 11, it says use the quadratic formula, find the solutions to this quadratic equation. So here's your equation. It says write your solutions in the most simplified radical form as possible. So here is how our answer is going to look. It's going to look something like this at the end. So first I want to label these. So this number should be a 1 right here, and that's your A. Then I have B in front of X, and then C is the one that has no X with it. So 1A, B is 8, and C is 11. Here, I did give you the quadratic formula to get you started with it. So X equals negative B. Well, B is 8. So I would say negative 8. Then I've got B squared, so 8 again, squared, minus 4. And we have talked about that when we have numbers together like this being multiplied, you're using parentheses around the A and around the C. So I would have parentheses, A, which is 1, and then parentheses again for C, which is 11. And then at the bottom we have 2 times A, again, parentheses, so 2 times parentheses 1. And then I want to break down each part. So I've got 3 parts, the first, the second, and the third. So here I'm going to keep the negative 8, negative 8. I also think it's pretty easy to do the bottom part. So 2 times 1 is simply 2. Now, inside of the radical, we have 8 squared, which is 64. And then for this part, you're just putting in the calculator of negative 4 times 1 times 11. You treat that minus 4 like a negative 4. Negative 4 times 1 times 11 is negative 44. So I would need to simplify this radical again by taking 64 minus 44. So 64 minus 44 would be 20. Now, if I look over here, I don't have this exact answer. I've got something very similar to it, but they didn't divide by 2 like they should have. So this means that we can simplify the radical, and that we learned in 7.5. So the quadratic formula itself, it was in 7.6. But to learn how to do the radical was 7.5. So you take the 20 and you break it down. So 4 times 5 can be 20. And then I break down that to be 2 and 2. So these numbers are the end of my branches. That's what I write down. And I see I have a pair of 2's. So to rewrite this square root of 20, I would rewrite it as 2 radical 5. So let's do that. So the square root of 20 is now 2 radical 5. We also discussed that if all 3 sections, the number on the outside of the radical here, if these 3 numbers can be reduced, you can reduce them all. So I can divide all of these by 2. So 2 goes into negative 8, negative 4 times. 2 divided by 2 is 1. 2 divided by 2 is 1. So my answer would look like this. But all of these 1's right here, if it's in front of the radical or at the bottom of the fraction, you don't need them. Okay? So my final solution is negative 4 plus or minus the square root of 5. So that would have to be the third choice. Oops, I just threw that across the disk. We do have one more problem like this in number 12, but it comes out really nicely. So you have one where you have to apply simplifying the radical. And then here we're going to have one that is just much nicer. Okay. So for this one, again, we would need to label our problem. So A, B, and C. So A is 1, B is -6, and C is -7. So it is important to note that B is -6. Okay. To plug in, we have a negative from the formula, and we know that B is -6. And 2 times A at the bottom is 1. Okay, and then I fill in the radicals. So B, again, is -6 squared minus 4. Remember, parentheses, so A in parentheses is 1 times C, which is -7 in parentheses. Okay. Now we can simplify each part. So the very first part, we see that we have 2 negatives. Automatically, you should know that that becomes a positive. So x equals +6, or you can just put 6 here, plus or minus. And then it's also easy to do 2 times 1 and get 2. Okay, -6 squared is -6 times -6. That is a +36. -4 times 1 is -4 times -7 is +28. Again, in the calculator, you could just do -4 times 1 times -7. Looking at this part of the problem, we just need to add that. So 36 plus 28 is 64. And 64 is a perfect square. So the square root of 64 is 8. So if it's a perfect square, I don't write the radical. And then what I do is I branch this off. So I would say I have 6 plus 8 divided by 2. And I have 6 minus 8 divided by 2. So 6 plus 8 is 14 divided by 2, which is 7. 6 minus 8 is -2 divided by 2, which is -1. So my two answers are 7 and -1. Okay, again, this came from 7.6 notes. I will tell you that on the test, it will tell you to go back and look at the notes at a particular problem in 7.6. So during the test, I would have your notes handy. It's very wise. Okay, 13. Actually, 13 through 17 are simplifying radicals. So 13, this is pretty awesome. These are perfect squares. So the square root of 49 is 7. And the square root of 64 is 8. So I'm looking for 7/8. Okay. For 14, 12 is not a perfect square. So I got to break it down. So we could say 3 times 4. You can use 2 and 6 also. You'll get the same result. 4 breaks down to 2 and 2. So here are the end of my branches, 2, 2, and 3. I also have 4 x's. So now I find all my pairs. I have a pair of 2's and a couple pairs of x's. So my pair is a 2xx. 2xx is 2x squared. And then because the 3 is left over, it goes back in the radical. So that answer looks like it would be B. Okay. For 15, we need to break down 300. So I'm going to use 10 and 30. So 10 would be 2 and 5. 30, 5 and 6. And 6 breaks down 2 and 3. So it looks like I have 5 numbers here. 2, 2, 3, 5, 5. I have a pair of 2s and a pair of 5s. So 1, 2 times 1, 5 is 10. Leftover 3 goes inside the radical. So that would be C. Okay, number 16, the square root of 25 is 5. The square root of 100 is 10. But as you can see, 5/10 is not on here because the 5/10 can reduce to 1/2. So that would be A. And then number 17, the 40, breaks down 5 and 8. 8 breaks down 2 and 4. 4 breaks down 2 and 2. So I have 3 2s and a 5 and 6 x's. So now I circle all pairs. I have a pair of 2s, pair of x's, pair of x's, another pair of x's. So this means that on the outside I would have 2x to the third, 3 groups of x's, and 2 and 5 are left over, so I multiply these to get 10 and put that back inside of the radical. So that would be A. Okay, we only have 3 more questions. Okay, number 18. So which method would you use to solve each quadratic equation? So on the test, you actually will click on like this box right here, and you will drag it, and you'll put it wherever you think it goes. Okay, same thing. So you'll click on it, and you'll just drag it to the location it goes to. Obviously, on a piece of paper, I can't drag, so I just wrote draw lines. But note, you're going to click it, and you're going to drag it to the right place. All right. So first thing, if I had you guys solve for x here, how would you do that? Well, here are your 3 choices, okay? We actually talked about all of these, but we're concentrating on factoring, quadratic formula, finding square roots. So finding square roots, this is when there was no x. So if I look, I have 6x, 11x, no x. Okay, so that means I would subtract the 14, and then I would square root both sides. That's where I get the square root from. So these 2 would go together. Then when I look at these 2, because there are 3 terms, you do x factor. So for this one, 1 times 2 is 2, and I'm trying to get to 6. Well, factors of 2 are 1 and 2. 1 and 2 cannot make 6, right? That makes 3, or I can subtract and get 1. So this is not going to work. So when it doesn't work, when x factor does not work, we do quadratic formula. Okay. Then we see, oh, we got 3 terms again. So 1 times 18 is 18. Trying to get to 11. Can any of these factors get to 11? Yeah, 2 and 9 can. So this is factorable. I can do x factor. So that would go to factoring. Okay, last but not least, for number 19 and 20, you have to figure out what pattern exists here in the y's. So for this particular one, we're looking at the y's. Okay, from 8 to 14, could I take 8 times something to get 14? No. Could I add? Yes, I could add 6. Does 14 plus 6 give me 20? Yes. 20 plus 6 gives me 26. And so forth and so on. So because I used addition, and it's the same number, adding, that's linear. So linear, I either have to add or subtract, same number. Okay. In number 20, I could do 5 plus 5 gives me 10. Does 10 plus 5 give me 20? No. So now I can, can I multiply? 5 times what gives me 10? Times 2. 10 times 2, does that work? Yep. 20 times 2. Yep, I get 40. 40 times 2, I get 80. Okay, so here, this is exponential because I have either multiplied or divided by same number. Okay, so if that was like 80 divided by 2, it gives me 40. 40 divided by 2 gives me 20 if it was backwards. Multiply or divide, exponential. Okay, so hopefully this helps you guys review a little bit. Go over whatever you need to go over again. Take good notes on all of this. If you can print it, that's great. If you can't, just take your own good notes on it to help you with your test. Good luck. Hope everyone's doing well.